So the graph of the function given here as this red curve over here, right? And our goal is to find the value of each of the quantity that is given over here if it exists. So let's try to find the limit of the function f of x when x gets closer and closer to 1 from the right side, right? So that's what that plus sign means. So where is 1 on the x-axis? So it's somewhere over here. Let's go closer and closer to 1 from the right side. So whenever we go closer and closer to 1 from the right side on the x-axis, the y values, which is determined by this curve, is actually getting closer and closer to this hole over here. What is the location of that? This is look like actually at 3. So if that is the case, that is the limit of the right side limit of the function at 1. In a similar way, to find the limit of the left side limit of the function when x gets closer and closer to 1, the left side limit that is determined by that notation, that minus sign on the superscript, right? So that's why we need to go closer and closer to 1 on the x-axis from the left side. So when we do that, you can see the y values is actually getting closer and closer to this solid dot over here. So if that is the case, it's somewhere over here, and that location is actually equal to 5, right? So if that is the case, 5 is the left side limit of the function at 1. But now to find the limit of the function over here, the limit of the function, to find that we need to check what is the left side limit, which is 5. We need to check what is the right side limit, which is 3. If they are not same, then actually limit does not exist at 1. So if that is the case, we can write down does not exist, or in the abbreviated form you can just maybe write down DNE, which represent for does not exist. At least I would understand in that way, okay? Or you could just literally write down does not exist. Okay, so that's what happening over here. So remember always, if the left side limit is different with the right side limit, then the limit does not exist. Now to find the value of the function exactly at 1, so if this is 1 over here on the x-axis, we need to see what is the y value. So this may be determined by this height, but there is a hole, so that's not the value. But you can see the value of the function exactly at 1 is determined by this solid dot, which is actually over here at, what is that location, 5. So if that is the case, f of 1 is actually equal to 5. And that's how we find this quantity.